Hi, I'm Osamu Akiyama from Osaka University Hospital. I'd like to present you my sixth-place solution of RSNA STR pulmonary embolism detection. I participated in this competition as a solo team. My kaggle account name is Oski Art. I'm a medical doctor and a first-year resident. Here is our overview of my solution. 2D CNN for image level feature extraction, and 1D CNN for exam level classification. In stage 1, I trained 2D CNN with trainable CT scan windows. I use efficient B0 and B2 as a 2D CNN backbone. I use trainable CT scan windows proposed in this paper. The windows were initialized with lung, PE, and mediastinal conditions. The training conditions are as shown here. I extracted the output of the gap layer as the features and use it for the input of the stage 2 model. In stage 2, I trained 1D CNN for exam level classifications. As input, I use feature sequences. Feature pooling, SE module, skip connections are employed in the models. Simultaneously, training of image level prediction was also performed as multitask running. I used unit-like up-convolution architecture and trained the model with two losses, vanilla BCE and BCE with weights that implement the competition matrix. The training conditions are as shown here. I averaged the prediction of stage 2 models following stage 1 efficient B0 and B2. I did post-processing to solve the conflicts of level consistency with minimal modification. The 5-fold CV scores are shown here. For the exam level classes, my model scored 0.196 in the competition matrices. For the image level class, my model scores 0.207 in the competition matrix. The total loss my model is 0.201. On the leaderboard, my best model scores 0.160 in public and 0.156 in private. I compare some model conditions after the competition deadline. This is the result of stage 1 models comparison. Scores are calculated without any weights. The result suggests that the number of epochs is enough to converge. Input size of 512 is better than 256. Input size of 640 may be better than 512. Cutout WSO mix-up may not be necessary. This is the result of the stage 2 models comparison. Scores are calculated with weights of the competition matrix. The results suggest that the training with vanilla BCE may not be necessary. LSTM and GRU may be able to achieve the same performance as CNN. Here I show some related links and references. Thank you for your attention.